Okay, so our new topic is water quality indicators. And we're going to look at water quality. And when we hear the word water quality, typically the first thing you're going to think of is how clean the water is. And that's part of water quality, but we also need to look at it under the frame of health of the water, because the health of the water is important in that if the water is not healthy, then it's going to cause a kind of a ripple effect, and the ecosystem that that water body is in is going to be not have good quality, not going to have access to good water. The plants and stuff are not going to be able to survive because they're not going to get the nutrients from the water that they need. Animals are not going to be able to live there because they're not going to be able to get healthy water to drink, clean water to drink, things like that. So those are really the two indicators that we're looking at. You have a digital version of the notes. When you click on this link right here, it's going to take you to Google Drive. You will do File, make a copy, entire presentation, and then you can edit your note guided note sheet that way. The notes that you're going to take are going to come from this Google slide deck here. And so I've got on the note sheet that you're going to fill in, there's orange text boxes that say type here. You'll just delete the type here and you'll type your answer or that blank, that note in that section. All right, so this is a 2-day assignment. It is assigned today as well as tomorrow, the 1st, today the 30th and tomorrow the 1st. I have on here for breaking it down that you do slides 1 through 8 today and slides 9 through 15 tomorrow, and that's referring to this Google slide deck that's embedded here. This Google slide deck covers the standard, covers standard 8E11, I'm sorry, 8E13, where we are looking at the safety and potability of water supplies in North Carolina based on the physical and biological features or factors, including temperature, dissolved oxygen, pH, nitrates, phosphates, turbidity, and bioindicators. So by the end of covering this unit or this section, we're going to be able to see what makes water potable. Potable is it clean? Is it healthy? Can we use it? So several things go into that. We're also going to look at how turbidity, temperature, pH, and dissolved oxygen can affect the health of the water system. We're going to look at what bioindicators are and how they help us determine the health of a water system. And then we're also going to look at what the EPA, which is the Environmental Protection Agency, is and how they help keep our waters clean. All right, so when we're looking at water quality, we are looking at the health of a water system. There are several factors that go into this, and it's a balance between physical, chemical, and biological variables that determine the health of a water system. When we're looking at physical variables, we're looking at temperature. Not necessarily in terms of is it hot or cold for us as humans, but is it hot or cold? How much heat is in it for the plants that live there, for the animals that live in the water system? Because all of that affects the amount of nutrients that are in there. The temperature of the water affects the amount of nutrients that are in the water and how much can be in the water. So we're going to look at temperature. We're going to look at turbidity. Turbidity is the amount of cloudiness or clearness of the water. If you have, let's say, a big rainstorm comes through and there's lots of erosion in your near a body of water, then that water is going to turn much more muddy and murkier. Excuse me, muddier and murkier. Due to that erosion runoff. If you have a creek near your house, I'm sure you've seen this. If you've driven by Creekside Park, anytime there's been a big major rain event and you see the creek flooding, the creek looks much, much more different once it floods. It looks around here, we have kind of the red mud, the red dirt. So the water in the creek, it looks really muddy, murky, kind of orange brown color compared to how it normally looks when it's just, the somewhat shallow creek that runs through the park. Um, I know if you've gone through and seen it, kind of covers, it can at some points cover the baseball fields that are there. It goes up and covers the trail that's there, and you can't walk on all parts of the trail. So all of that would have an increased turbidity. And then also the rate at which the water is moving. Those are kind of the physical variables that come in with water quality. On the chemical side of things, we're looking at the amount of dissolved oxygen. the amount of other gases that are dissolved in the water, the pH, which is the percent of hydrogen. We talked about this briefly in the chemistry unit when we're looking at pH. If in a solution, if there are more hydrogen ions in that solution, then it's going to be more acidic. And if there are more hydroxide ions, it's going to be more basic. So we'll look a little bit deeper at that pH scale. Nitrates and phosphates are two other chemicals that we look at their levels in a water system. Nitrates and phosphates are chemicals derived from nitrogen and phosphorus, and they come from pretty much the way they get into our excess amounts of them get into our water systems is through the use of fertilizers on um, farms, on entertainment venues, golf courses, things like that. Um, there's a stream that runs on the campus of Trinity High School, and some of the classes there in one of the in the ag department in the CTE department is natural resources, and one of the activities or projects that their class kind of does is they monitor and keep track of the um, water quality of that stream, and they do several field trips, or they do field trips with a lot of the elementary schools, and the kids go from the elementary school to the campus of Trinity High School, and they go to the creek, and the students in the natural resources classes actually lead the activities where they're testing dissolved oxygen, where they're testing for turbidity. They're taking the temperature of the water. They're showing these kids how to do all of these water quality testing things. And they can always see. They told us because we went with the group from Braxton Craven, the STEM club a couple years ago. One of the things that they can always see is when they fertilize the football field, because that water and those nitrates then run off, of course, into that stream, and so they can test they can see the major increase in nitrates and phosphates when that football field is fertilized. We're also going to touch briefly on salinity, which is how much salt is in the water. And then we're going to look at the fish, algae, insects, and plants that are located in there. Those are our biological factors. So, by looking and seeing what organisms are in the body of water, we can see and kind of tells us what type of health the water is in, because certain types of organisms do better under certain conditions, and if those conditions are present, then those organisms are the organisms that are going to be there. Some organisms do really, really well in unhealthy water systems. However, they're the only organisms that are there. So if we only see organisms A and B, that tells us that the water quality might not be that great there, because those are the only organisms that we see. Let me touch just a second on dissolved oxygen, because it kind of pulls in that plant aspect and the algae aspect. Dissolved oxygen is not the oxygen in the water molecule. It's not the O in the H2O. It is the oxygen that is in the water, kind of free floating within the water, along with those water molecules. How does that oxygen get there? It gets there through photosynthesis. Everybody knows that through the process of photosynthesis, plants take in carbon dioxide and sunlight and water, and then they release oxygen into the atmosphere. And that's the oxygen that we then breathe. In um, on the planet Earth, the majority of our um, the surface of our planet is covered in water. So the majority of the um, oxygen that we breathe, we tend to think that we know that it comes from plants, but we tend to think that all of the plants on the surface of the planet, like the trees and the grass and the flowers and all that kind of stuff, are where we're getting the majority of our oxygen. That's actually not true. The majority of the oxygen that we breathe in comes from the oceans and all of the aquatic plants and the algae that are in the oceans that go through photosynthesis. They release that oxygen that they create through that process into the water. And that's the oxygen that fish and other aquatic organisms take in as they breathe in the water. So the fish pull the water through their gills, and as they do that, the oxygen that's dissolved in that water kind of sticks to their the capillaries in their gills, and then from there, that's the oxygen that they use to breathe. And then as that water, as the oxygen, the dissolved oxygen that's in the water, kind of reaches the surface, that's when it's released in the atmosphere, and we get access to that. So that's just a touch on dissolved oxygen that kind of ties in the plants and the algae that are there as well. All right. So I'm going to stop here with this information because I don't want to, give everything away. Um, but you're going to use this information, this slideshow, to complete the digital version of the sheets or of the notes, and you cannot submit your completed notes until tomorrow. So that's Tuesday the 1st. So make sure that when you're finished with your actual notes tomorrow that you do submit them here on Canvas.